There it is. It's what root is that? That's fifth root of what? 1 to the 20th. Okay. So what does fifth root mean? You're searching for a number that multiplies by itself how many times? So it's the fifth root of 32. 2. So you know that this is 2 times the fifth root of y to the 20th. What power is fifth root? 1/5. So this is 2 over y to the 20th to the 1/5 power. What do you do with powers of powers? Yeah, so what's 1/5 times 20? 2 over y to the 4th. Done. So let's say you had the square root of, 3 million like this. You can do that as the square root of 3 times the square root of 1 million, right? Is that enough zeros right there? Yeah. What's the square root of a million? What times itself is a million? 1,000. Yeah. It's 1,000 times the square root of 3.
No, I mean
like what? Yeah. So the point is you can go, but here's the thing: if you wanted a decimal equivalent of that, you need to figure out what the square root of 3 is. In decades past, before calculators, kids were taught when you learn long division, there's a method that looks a lot like long division for square roots. There's a way to find square roots by hand to an arbitrary accuracy level. So do a radical like this. What do you need to do to 128? Oh, did I not do it right? 57? Oh, that's the wrong 57. That's sorry. It's sorry. 57 is negative fifth root of 486. Good question. Now, what does that negative do? It's just what? It just stays there until you get the end. So what do you need to do to 486? Yeah, you need to factor. So what should you pull out first? Pull out 2. And you get 240 what? 3. And what is 243? That's 3 times, oh, wait, you might recognize, what is 243? Oh yeah, we can do it that way. That's fine. Yep. So it's 3 times 81, and 81 is 3 times 27 is 3 times 9, and then you have 3 times 3. So what is 243? What's another way to write it? What do you see? You should know this. We've done this before, or you need to memorize this. 243 is 3 to the 5th. Look, how many 5s, how many 3s do you see? Right? So if we rearrange this, what is this? This is negative fifth root of 2 times 3 to the 5th. All I've done is I've rewritten 486. What does fifth root mean? What power is fifth root? 1/5. So you have negative the fifth root of 2, but then you have 3 to the 5th to the what power? What is 3 to the 5th to the 1/5 power? So the answer to this is negative 3 times the fifth root of 2. That would be the final form right there. You can't go any further. You can't go any further. Yeah, pull out what? Pull out 2. Pull out the easy stuff. So it's 700 and what? 29. Do you recognize 729?
Yes.
729 is 3 to the 6th. So this is, you could just keep on going. Keep on pulling out 3s and you'll get 6 of them. So this is the 6th root of 2 times 3 to the 6th to the what power? Yeah, what is 3 to the 6th to the 1/6? So this is 3, and you'll notice I'm going to put some parentheses there. 3 times the 6th root of. Why do I put that parenthesis around it?
So that we don't get the 6.
Yeah, it's really easy. If I wrote this clearly, you'd be like 3 to the 6 times root 2 or 3 times the 6 root 2, which are completely different, right? Completely different. 3 to the 6 is a very, very, very big number. It's 729. So if you didn't memorize that 729 is 3 to the 6, you would see it eventually, because what's the only thing you can pull out of 729? 3, and then 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 3. Detail that you need to show, but then there's a certain level of detail that's overkill. So for example, just because you have a hammer doesn't mean you need to hit every wall you have, okay? Just because you have a hammer doesn't mean, so you don't need to do a factor tree, for example, or you don't need to write it as the most, I understand it just takes practice, but what I'm going to try to give you is the most effective pathways through these. So one way to talk about this is, instead of writing it like that, you could write it as all of this to the what power? You are square rooting everything. What is the square root of 144? 12. And then it's going to be x to the 3 over
3 over 1 times 1 over 2.
Exactly. 9 to the 9 over 2.
Yeah.
That would be what I would look for right there. That would be what I would look for. What does cube root mean on the second one? What does cube root mean? What power is that, Mark? Exactly. The power is y to the 17th over 125 to the 1/3, right? Is 17 evenly divisible by 3? No. So the only thing you can do is write it as y to the 17 over 3 over the cube root of 125, which you should know is 5. Leave it like that. That's done. That's fine. You could also write it if you wanted to as parentheses 1/5 times y to the 17 over 3. What about this one? Is 16 evenly divisible by 3?
Yeah.
It is?
No.
I don't think so. Over the 27 to the what power? 1/3. What is the cube root of 27? 3. So this is just x to the 16 over 3 all over what? Which you could write as 1/3 x to the 16 over 3. You could write it like that. Yes, you could. You could. Does that make sense? Okay, get back to the board. There a fourth root of 81, is there?
Yes.
Yeah, it's going to be 3, and then it's going to be x to the 12 divided by 4. What's 12 divided by 4? 3, y to the 4th. So those divided evenly. That's nice. What about this one? You maybe did a factor tree. You're looking for the largest square factor of 500, which is going to be 100. So square root of 100 is. So first you could pull it out and make it negative 10, and what's left? Root 5. But then you're left with r to the 11 over 2. Stop. You're done. Put everything away except the pencil. There are 3 things I could ask you to simplify. Let's take a look at this one right here. Could someone tell me what that equals? Anybody want to take a guess? The first one there that I used green to highlight. Can anybody tell me what that equals?
7.
It is.
No, it's not 7.
Final what? 7 is in the answer, yes?
7.
It is 7 square roots of 2. That is correct. You are done. 4 apples plus 3 apples is how many apples? 4 root 2 plus 3 root 2 is? It's the same exact thing. Nothing changes. It feels like something should change, but it's addition. But what happens if you have 3 apples and 4 oranges? Can you combine the apples and oranges without a blender? No. Addition is not a blender, okay? What about this one right here? What about 2 root 3 minus 5 root 3? Exactly. It's the same exact thing. This is negative 3 square roots of 3. Okay, let's go for the gold here. What about this one? Yeah, it already started. Game's already started. Yeah. I didn't know that apparently since 2010, certain qualifying events have to start before the opening ceremonies. Didn't know that. What's different about this one?
It doesn't have the same.
It's not the same. It's not an apple and apple, right? It's an apple and an orange. So we need to see, is there any way to use math to translate them into each other? So first of all, let's say I just gave you 3 times the square root of 24. Right there. Let's say we were just doing this one. How would you simplify? What would be the thing you would do to simplify the square root of 24? Try to factor it. And you want to look for that, it pulls out a 2 and a 12 and a 2 and a, and a 2 and a 3. What's the only pair of numbers you can pull out?
2.
So what's this going to be?
Wouldn't you have the 3s, the 2s?
No, it's square root. So it's square root, right? It's only a 2. So what is it going to be? So this is going to be, the square root of 24, we now know equals 2 root what? But what came down from here? 3. So what is the final answer on this one? 6 root 6. So let's go over here and look. What's 54? What can you factor out? And what's left? And then you get 3 and... Not 3 and 3, right? That's probably not correct. 3 and 9. And what else can you pull? Oh, what did you pull out of there? 3 and 3. It's a square root, so what can you only pull out? 3. So what do you get? 3 square roots of 6. Oh, so now what do we have? 6 square roots of 6 plus 3 square. Now can we add them? How many apples do we have? Yeah, and it's nice. Apples are just the square root of 6. So just because you have a showstopper right there doesn't mean you can't proceed. You will practice that and you will proceed, but you have to recognize, can you just straight off add square root of 24 and straight of square root of 54? Not yet. You need to modify them a little bit. You need to cut them up a little bit and resize them without losing any of their pieces. X has to be greater than 0. Why does this? And what kind of root is it? Is it odd or even? It's an even, right? So you can't do an even root of a negative number, or it's imaginary, which we're not doing yet in this class. So on this one, do we have just apples on this one? Yeah, we don't. We have, I mean, what's underneath the radical is not the same in both cases, right? So we should try to simplify. So on this one, what number are you factoring under there? 20. What can you pull out first? 2 and 10, 2 and 5. So what can we pull out? 2. So we end up with 2 times 2 is going to be 4, right? Square root of 5x. The x is still in there, right? Minus, well, what can we pull out of 45? Well, 5. Pull out the smallest things first. 5 and 9, and then what? 3 and 3. Pull out the smallest things if you can. So what can you pull out here? You can pull out 3. So what's it going to be? 3 square root of 5x. Oh, now do we have the same thing under the radical?
Well, you can't multiply those two threes.
You do, but the whole point is that this thing right here, Nick, is equal to the square root of 5 times 3 times 3 times x. And that's equal to the square root of 5 times the square root of 3 times 3 times the square root of x. What is this right here? What is the square root of 3 times 3? 3. So this is 3 root 5 root x. So we put them back together and end up with 3 root 5x.
Oh, and why did you multiply the two on the other side?
Because there was a 2 sitting out front. Sorry, you see the 2 sitting out front already? There's nothing out front of this one, you see?
Oh, okay.
So it was, yes. I did Nick, that's a very good observation. I did 2 steps in one right there. I did this. It's really that right there, see? That's where this 2 comes from, that's where that 2 comes from. So now you have 4 of them, and you're taking away 3 of them, so what are you left with? Yeah, just one of them, right? 1 times this, and do you usually put that 1 in front? No, so you end up with just that. So once again, there's no truly new math here other than you can't just put together things that have different things under the radical. They have to be the same root and the same thing under the radicand, the symbol. So let's 2 root 3 minus 4 root 5. What do you think? I like the shaking of heads. Can you go any further? No. 5 is a prime number, 3 is a prime number. This right here, there's nothing you can do to simplify. That is most simplified. So don't force it. Remember, if you have a hammer, you don't need to put holes in the sheetrock. On this one though, it doesn't have it has this, and luckily, what does it have? It has the same root, right? Third root, or things get much harder. But is what's underneath the same? No. So we're doing cube root, so we're looking for factors that appear 3 times. So the biggest cube. What can we pull out of 8? What can we pull out of 16? 2 and just so you can see it, it's 2 and 4 and what else? 2 and 2. So we're looking for a triple. What's the triple?
2.
There's 3 2s, right? So Nick, you see there's already a 2 out front. So we're going to pull 1 2 out, and there's already 1 out front. So it's going to be 2 times the cube root of what? A lot of 2's there. So this 2 right here goes there. This one went right there. And this one. Now, you see how that kind of looks like 2 to the third down there? Is that 2 to the third? No, what is it? Cube root, right? So to fully simplify this, we now have 4 times the...
Circle 3.
I'm circling because what root is it, Nick?
Oh, okay.
Cube root. So over here, we need to do the exact same thing. What can we pull out of 54? Remember, pull out the 3 and what? 9. Sure. You know what? Some of you like to do that. I'm not going to stop you from doing that. But if you do this, just make sure you keep going. What is 6? 3 and 3. What can we pull out?
3.
So what's you got? Oh, look at this. And there's a 5 out front, right? So you pull out a 3, and you're left with the cube root of what? Cube root of 2, right? It's 2 right there. See? This 3 went This 3 went right there, and that 5 went right there. So how many do we have there? What's 5 times 3? 15 times the cube root of. So 4 minus 15 is negative 11 times the cube root of 2. Done. Excellent, excellent, excellent. Just keep in mind what root you have. It's cube root. Oh, here we go. We're getting close here. Getting close. I must have hit the. You know what? I must have hit the. Sometimes I do that. I hit the power stroke. What could you do? You could write it in 3's. Thank you. It could be the cube root of x to the 5th and the cube root of y to the 4th. Now, what is the cube root of 8? This is 2. So let's just take stock of what we have right now. We have 2 times the cube root of x squared y, put that in parentheses, plus 2 times the cube root of what? And it looks like, are we getting closer? Kinda, right? We're kind of getting closer, but the problem is, can you just add these together and make it 4 times something? No, you have to be very careful about this. So at this point, I would start, this is radical form with some exponents in there. Let's try just getting rid of all the radicals. If we did that, you'd end up with 2x to the what power? 2 over 3. And y to the 1 over 3 plus 2x to the what? 5 over 3, and y to the 4 over 3. Are we close? What's the problem here? 2/3 is not the same thing as 5/3. And another problem is 1/3 is not the same as. This one you have to pull out and break apart. So this is the first really new tactic. This one you keep the same because it's kind of smaller. Plus 2, is this legal? Am I allowed to do this? X to the 2/3 and x to the 3/3? Is that allowed?
Yeah.
Because this, do you see this? What is 5/3? How many thirds do you see right here? I see 5 of them, right? And then y to the 1/3 times y to the, oh look, is that the same thing? That's the same thing. But now, what can you factor out of both of these? X to the 2/3 and x to the 2/3, and what else can you factor out? And y to the 1/3. So this is true. This is the first truly new thing about this. So what is it? Oh, can you factor out a 2 as well? Oh, look. So what is it going to be? It's going to be 2x to the 2/3 y to the 1/3 parentheses. What do you have to put in there? 1. You have to put a 1 in there, right? Plus what? X to the 3/3 y to the 3/3. But what is 3/3? So what do you end up with? 2x to the 2/3 y to the 1/3 times 1 plus. This is a hard one. This is the first brand new one we've done. This is harder. This is harder. This is harder. Okay.